Good morning. I hope you guys are enjoying the beginning of trigonometry. Today we're going to talk about something that will be applicable to all of our lives, linear and angular speed. And you're saying, what? Linear and angular speed? How could we need something like that? Well, linear speed is how fast a position of an object is changing. And what we have here is we have some variables that you're going to see from here on, okay? Especially in trigonometry. So the linear speed is distance over time, okay? Angular speed, and we're going to talk about these in depth here in a minute, and this is where we see, this is a fancy W, it's called omega. Omega is the angle that's changing over time. This is very important. The angle always has to be in radians. If you have it in degrees, it needs to change to radians. You must change it to radians for angular speed. And we have the omega is the angle that something is moving over the time. That linear speed, that angle in radians. When an object is traveling in a circular motion, it has both linear and angular speed. The linear speed is dependent on the radius of the circle and how fast the object is rotating. So we have another formula here for linear speed, and it is going to be the radius, okay, times that angular speed. And you can see that if you're going from here to Morganton or somewhere, the bigger the tires, if they're going at the exact same rotation, you're going to get there faster. You're going to be moving faster. Okay? If it's the radius is bigger, okay, and they're rotating at the same rate, then you're going to get there faster. So, what I'm going to do, I'm going to skip a lot of these because all you have to do is plug it in and solve. I have right here, my angular speed is pi over 4. It's already in radians. Okay. My t, time is 5. So I'm going to plug in pi over 4 for my angular speed, t for time, multiply it, and I'm going to get it. Okay. I'm going to let you do these. These are your exercises. I'm going to move over here to the back because this is what I want to do. 6, 7, 8, and 9. These are going to be, and I'm going to do most of these because they're going to be like your portfolio assignment this week. I want to show how to do this. We have a line from the center to the edge of a CD, okay? And it is revolving 300 times per minute. So I have a CD, okay? And I want to know from the center to the edge how far that is. And I know that this is revolving, okay? And I am told that it is revolving 300 times per minute. So what we can say here is my angular speed, that's what I'm asked to find, is it is going 300 revolutions per 1 minute. Okay, so I've kind of got it like we had on the front side, 300 revolutions per 1 minute. But how many radians are in here? We know that it's 360 degrees, and we saw last week that this is 2 pi radians. Okay, there's 2 pi radians in 1 revolution. So if I do this calculation, my revolutions are going to cancel, and I get that my angular speed is 600 pi radians per minute. That's what we're going to be doing with these. Okay, now let's look at the second hand of a clock, number 7. The second hand of a clock. I know that my angular speed, it's going to do 1 revolution, and a second hand takes 60 minutes. 60 minutes to do one revolution. Okay? So in one revolution, there is 2 pi radians in one revolution. So my angular speed then is pi over 30 radians per minute. Please come to me if you have any questions. Okay? Got 2 more. Okay? Now we're looking for the linear speed. So the tip of a second hand of a clock, if the hand is 28 millimeters long. So I know that my formula is the radius. I'm going to use this one because the tip of the hand, it is 28 millimeters long. The radius times that angular speed. So my linear speed is the radius, 28 millimeters, times pi over 30 radians per minute. How did I get that? There are 2 pi, okay, like we did up here. There are 2 pi, okay, radians in one revolution. And it will be, there's one revolution in 60 minutes. Okay, so that's where this came from here. Now, when I do this calculation here, now is when I'm going to go ahead and I'm going to go ahead and estimate this. So give them a little estimate. 2.93 millimeters. Yep, millimeters. I had to see what it was in per minute. So these are simple calculations and they are difficult. And these are what you have 3 of these to do for your portfolio this week. So that's why I'm doing all of these and then letting you do the other problems, 1 through 5. Okay, let's look at the very last one. A point of the thread of a tire radius, 18 centimeters, and it's rotating 35 times per minute. Woo! Okay, so I'm going to have same formula. My linear speed is my radius, 18 centimeters. Now, what am I going to do here? If it's going 35 times per minute, okay, so my angular speed, it is going 35 revolutions in 1 minute. And I know there are 2 pi radians in 1 revolution. All right? So my W here, I'm going to calculate that right here. And that is going to be 70 pi radians per, what am I doing? Minute, per minute. Do my calculation, and 18 times 70 is 1,260 pi centimeters per minute. And that's the perfect, that's the perfect one. And this is approximately 3,958.4 centimeters per minute. Remember, I am here 10 to 11 and 2 to 3 every day if you need help. Have a great day. Goodbye.